So here I've got a Linn Kairn Pre-amplifier, and this is a well-regarded preamp, and of course it's made in Scotland, and it powers up okay. There we are. See the volume going up to its previous level, and so it's functioning, but the owner's complaining that the noise floor is high, and then when it's powered down there's all sorts of clunks and bangs coming from the loudspeaker. So we're maybe expecting a power supply problem here, but we'll see what we find. And then this little flap here that covers the buttons is obviously a bit questionable, so we'll see if there's anything can be done about that. Maybe we'll connect this up and make some measurements before we take this one apart and see what it shows. So I've had a listen to this preamplifier now, and definitely agree with the owner that the noise floor is high and there's some pops and bangs when you turn the thing off. So we need to kind of quantify that somehow so that we can begin to find out where these problems are coming from. So what I've got here, I'm looking at the audio analyzer, and I've got just a Cyrus 8 amplifier, and I'm looking at the preamp output from that, and we can see in this measurement the noise floor is about minus 150 dBV, nice and flat, and all good. When we look at the Linn, what we find is the noise floor is a good 20 dB higher, so that's 10 times higher, and that's clearly not right. The interesting thing here is it's flat. There's no kind of signature going on there. It's just a raised noise floor. So that tells us something. I'm not sure what, but just something to pay attention to right now. And then we can see the noise levels here. As I say, these are almost 10 times bigger on the Linn, and so we'll just use these numbers as a reference, and we'll go on from there. So I guess we'll take the covers off now and we'll have a look inside this thing, see what we've got to play with. Here we are then, and this is another one where I don't have any schematics or any background in this guy at all, so everything we're doing here is just finding our way. There's some obvious things we can see of it, and we can make a start on that. So the first thing is, this is the power supply here. There's a few options for power supplies in this, or two options rather. We can have a traditional linear supply, or this is what's modestly labelled brilliant supply, and it's supposedly a quiet switch mode supply, and then the rails for that come down onto the main board. We've got some extra filtering here, and then there's some linear regulators here to supply the rest of the board. So that's all good. Obviously our inputs and outputs are at the back here, and we can see that this here is obviously going to be one of our phono amplifier stages, whether it's MM or MC, and then I'm suspecting that this is the next, it'll be one or the other also, so I think these are related to the phono inputs as well. And then we've got a bunch of these DG309 analog switches here, so these are doing our input switch selection, and then after that there's an amplifier stage here, and that goes on to this device here. Now this is a multiplying DAC, and this is being used as our volume control, so this is an R2R DAC, and we can digitally control our volume from that. So we'll see how that is doing its job, and then after that there's another amplifier stage driving our outputs, so all good. And then these two devices here, these digital devices, this is a display driver, but I suspect it's not actually driving our display. When you look at how the traces are routed, they're going up to these analog switches. So I suspect it's just the logic in that we're using to control these switches. So we'll maybe dig more into that. But one of the things we can do here is, we've obviously got some outputs here for a tape, and that should come after the switching but before this volume control. So if we look at that tape output and then compare it to our main outputs, we can see that gives us a means to partition this circuitry, both before and after the volume control. So let's look at the spectrum of that. So here we are looking at the red trace here is the tape output on one of the channels here, and we can see that there is a bunch of junk on that, but in terms of the noise floor, that's actually better than our Cyrus unit, and overall we can see we're about 1.5 microvolts there, whereas the Cyrus was over the 2 microvolts. And then the blue trace is the pre-out from this thing. So we can see that before the volume control, our noise floor is just fine. We've maybe got some pickup with these kind of spurious things, but the noise floor is absolutely excellent. So it's somewhere around the volume control or after the volume control that we're getting all this extra noise coming in. So we maybe need to go and have a look around that volume control device and see what we can find there. So I was hoping that we'd find some obvious power supply problem in this thing, but they're all checking out pretty good. If I look at the power supply on this DAC here, on the red trace there, we can see it's below our output noise floor at the high frequencies at least. So I'm not worried about that at all. That all seems quite good. And we checked our output on the tape output. That worked just fine. And we can trace that all the way to the input of this DAC here. And again, I've got a signal on it this time, so you can see the peak there at 1 kilohertz. But the noise floor is fine. So what we're feeding into this thing is good. And the issue I've got is that this is a current output DAC. So I can't just probe the output and measure it, because the output is in a feedback loop with all this extra circuitry here. So that gives us a bit of a headache. And I'm somewhat nervous that this device is the problem, because we're looking for something that's common between the two channels. We've determined it's not power supply, at least in what I can see to measure so far. So we're looking for a common element, and this guy is it. I'm just nervous there's some leakage or whatever going on inside that device, and it's that's the root of our problem. If we look at replacements, however, what we see is that there's a fairly hefty £72. This is from DigiKey here, and so if we're going to look at replacing this, then we need to be doubly sure that that's the problem. So I think what we'll do next is we'll take this board out and we'll maybe try and isolate some of this stuff and see if we can maybe measure this output amplifier on its own, check the noise performance of that, and then build a picture around that. We'll maybe take this out, put it in a socket, but that'll be, I'll kind of leave that to last. So let's get the board out, see how we go on. Alright, so I managed to connect up the output, what I was assuming would be a buffer amplifier here. I've managed to connect that up in isolation, so we can look at it without the DAC being in circuit. And what you can see, I've got a few parts tacked on here to let me do that. And what I find is that the noise level is the same as what we've been seeing. And that's good news, because it tells us our DAC's not contributing anything, and so we can kind of forget about that. I was surprised, you know, we'd done some of the reverse engineering. I was surprised to find out just how much gain is in this amplifier. So if we look at our structure, you know, we've got our input, we've got our switching that we saw, and then there's this DAC that we're using as a volume control. And I would normally expect a buffer here, or maybe sort of 6 dB again maximum. We find we've got 14 dB again here. And so this is where our noise is coming from, and our noise cannot be attenuated by the volume control, because it's, you know, this amplifier is after the volume control. And when you look at Linn power amplifiers, they seem to have a bit lower gain than some of the other brands, and I wonder if they're just partitioning the gain somewhat differently between the preamps and power amps. And so if you go and connect this guy up to some other brand of power amp that's got a bit more gain than a typical Linn might have, then you're going to experience increased levels of background noise. That's just the reality. So everything we've been measuring is just coming from this guy. You know, if you've got 14 dBs again and maybe 4 or 5 dB noise figure in this thing, that accounts for the difference of the sort of 19-20 dB that we saw when we compared with the Cyrus amp in the first comparison. So what we're seeing here is characteristic. It's not a fault, and it's, you know, as I say, it's just going to present itself to different degrees depending on what power amplifier you're connected to. And so, discussing with the owner, what we're going to do is we're going to drop the gain here. We're going to do a little mod that will drop the gain, and that should drop the background noise in his system, and you know, make for a better experience really. And all that needs to happen then is that you know, the volume control is going to be set a bit higher. So what we'll do is we'll use one of these little jumper tag strip things, and we'll use that to flip between the standard setting of 14 dBs, and we'll flip between that and 0, or you know, we'll figure out what the right level is to have as a default, but we'll go for 0 initially and see what happens. So we'll do that. That's the plan. And also, when I was in here, I can see that particularly these black capacitors, the ESR on them is kind of high. So we're going to go and do a bit of a recap job on this as well. So we'll do that various bits and pieces, and we'll come back and make some measurements and see how our noise floor is looking after that. So here's our little jumper arrangement. We've got one here, and then the other one's just hiding behind that capacitor there. So to change between the 14 dBs again and 0, we just swap the position of this jumper here, and that's us. And so I've done a bunch of recapping as well, and we're should be ready to go now. So let's connect back up to the audio analyzer, and we'll see how our noise floor is looking. So here we are after we've done our little modification, and as it's set up at the moment, it's set with a 14 dB amplifier in circuit, and we can see our noise floors there. And if I go in here, and I just need to remove the jumper, if we remove that and we just look at the one channel, I need to reset my average in here, and we can see there that the blue trace is now significantly lower, and that's going to be the 14 dB lower. And again, if we look at these numbers, they're about 5 times different, which is the 14 dB. So that's all good. Let's just take the jumper off the other channel now and see how that behaves, and do a reset. And there we are, they're overlapping at that much lower level now. So that should be a significantly quieter amplifier now, or pre-amplifier rather. It's not, you know, it's not state-of-the-art noise floor here. We're still maybe not as good as some of the newer amplifiers, but in order to get to that point, we really have to kind of, you know, redo this whole output section here, and that's not what we're about here. That's not what this job's about. So we'll stick with that modification for now. We'll you know, run it for a while, see how it sounds, and go from there. So before we finish up here, we're going to take this power supply out. We'll have a look inside that, see what recapping needs to be done inside there. And then the other thing that was mentioned was the sort of pops and crackles when this thing's powered down. So we'll have a look at that and see what that's about. So while we're looking at changing some of these older capacitors, potentially dry capacitors, we need to look at this main power supply here. And we've got these 6 capacitors on the output that these guys are getting a hard time. So we'll go in and replace them. But it's also just an opportunity to have a look at this supply as well. And we can see we've got a bunch more filtering on the output than you would expect from your standard switching supply. These will be the plus and minus 18 volt rail filters, and then this I think is a plus, there's the other rail's a plus 10, which is probably coming from this guy here. And then we can see we've got some ferrite beads in series with the output, so these just take away some of the sting in the sort of high frequency edges that you might otherwise see. So this sort of extra filtering that's going on here, I guess, is why they're labelling it as being something a bit special. So that's what's going on there. So looking at the back, we can see our driver device here, and then our switch and power supply device, and there'll be some FETs on the other side that drive this main transformer here. And then there's our bridges going to these output filters that we saw. So all pretty classic stuff there. And we can see we're actually crediting the folks involved here. So it's designed by BM and DRR. And we've got a label here, Clyde built. Now Clyde refers to the River Clyde in Glasgow, near where Linn products are based. And there's some labels here for various parts of the test process, I guess, and the initials of who's been involved. So kind of traced through quite carefully. So that's all good. And we'll go now. We'll just replace these 6 capacitors here, put this thing back together and get it back in the main unit. So let's take a look at the output here when we power down. Let's just probe one of the channels here, and we'll do a single capture. And if we power down, take a second or two to do the capture, there we go. And we just see this dip here, and this is what we're hearing in our loudspeakers. We just get this pop. And this is just the power supplies collapsing, and we've got some funny offsets and things in the amplifier as the power supply is collapsing. And we're obviously hearing it. If the power amplifiers are on, I mean, the theory here should be that your power amplifiers go off before your preamplifier, and then none of this stuff would come through. Some amplifiers, or at least modern amplifiers, say they'll have a mute circuit that deals with this kind of thing during power off. This amplifier does have a mute circuit, but it doesn't cater for the power off situation. It's actually a mute circuit that has to be driven in order to make the mute happen. And of course, when you're shutting down, you don't have any power supply to be able to actually do that. So let's take a look at the action of the mute circuit here. So it's a JFET that's been used for the mute function here. And so in order to turn it off, it's going to be a negative voltage we're looking for. We're sitting about 0 volts on the gate here at the moment, so that FET is turned on. If we do a single capture and we power down, we see here that we get a negative voltage briefly, and it's going to turn that transistor off. But then as our power supply is failing, that negative voltage is just rising. And it just doesn't stay negative long enough to mute the effects of the power supply shutting down. And so again, this circuitry is behaving as it's designed. So I would say this again is a characteristic as opposed to any kind of fault that we're going to rectify. So that's just what we have. I mean, the deal, as I say, the deal is that we should turn our power amps off before we turn our preamp off. So there we go. Alright, so we're nearly done here. Last thing we need to do is change the battery in that front panel and see if there's something we can do with that little flap that covered the buttons on the front panel. So there's 5 screws there to get this cover off. And then I'm talking about the effort they've gone to here. You know, they've obviously got this shielded back cover. And then there's this little board here that does some EMC filtering for that ribbon cable. And then the front metalwork's a cast piece of metalwork there. So I think most of this is probably for EMC purposes, but potentially as well they're trying to limit the amount of digital junk that creeps into the analog circuitry. So on this board we've got there's a microcontroller on the top there, and then there's one on the underside, or an EEPROM or something, and then the 2 devices on the left there, they are display drivers. Where I'm pointing to here, this is the infrared receiver circuitry, and you know, nowadays that's just all done in the actual infrared detector itself. So we can see our battery there on the right that we're going to replace, and here I'm just removing these. There's 5 of these standoffs that I've got to come out. So we take them out, and then once we're done that, on the top right we've got a regulator, 5-volt regulator, and there's a screw for that, and it's got an insulating washer on it, so you need to be sure not to confuse that with any other screws. and we can lift the board out from there and go ahead and replace our battery. Right, so I'm just going to hold the battery on one side, and then we'll heat up each of these joints one at a time and gently persuade the battery loose. There we go. And then we can clean up these joints. That's us all installed. So we'll maybe clean up those joints with some alcohol. And we'll check these capacitors as well. Maybe not so as critical as the ones in the analog board, but we'll check they're not dry and replace them as need be. So the next thing we want to look at is this front panel flap that it wasn't closing properly and just behaving a bit randomly. And we can see it operating here. We've got some springs here on little pins coming out of this plastic thing here, and I can see what's happened is that these sort of hingy arm things here that's coming out of this thing, just over time they've obviously kind of splayed outwards, and we've got some big gaps here. And so what I think I'm going to try and do is we'll put some wire around between these 2 points here. We'll just try and pull that together a bit. I think that's sort of the simplest thing to try. There's obviously some sort of dampen material in this joint here to let it open kind of smoothly. So I'm not going to touch that because I don't know what it is, and I might just make things worse there. So we'll leave that alone, but we'll try and get a piece of wire to pull these things, pull these arms in, and give us a bit more reliable behaviour. So let's go and try that. Right, so here we are. I've just strung this piece of wire between these two plastic pivots here and soldered that together. So it just holds it a little bit tighter, just gives it a little bit more grip. Put all our standoffs back in and our screw for the 5-volt regulator. And if we look at our front panel now, it's opening and it stays closed, so that seems more stable. Not sure how it would behave when it was brand new, but that seems respectable enough operation here. So we'll leave that at that, and just go ahead now. We'll put this shield back on and get this installed back in the unit. Here we are after our battery replacement, then all the covers are back on, etc. And I think the first time we're going to power this on, we're going to get some error, which will then clear itself while the battery's charging itself up. So let's have a go. Error 2, don't panic. And then it's up to operating as normal, so that's all good. So we'll just leave that for a while, and that battery will charge up. Next time we turn it on, we shouldn't get the error. So previously I showed our modification inside where we had a little jumper for changing the gain of this amp, and I've changed how I do that now. When we look at the back here, we see that we've actually got 3 sets of line outputs, and these previously they were all in parallel, so they all gave the same same levels. And what I've done is left 2 of them original, and then this third pair here I've put the attenuator in so that we've got a lower gain there, and so that's going to be our lower noise output for amplifiers that have maybe got a bit higher gain. So that I think is more flexible than having the little jumper inside, and you can chop and change depending on what amplifier you're connected up to. So that's where we are. So I think we're just about ready to connect this up to some power amps and see how it behaves. So here's our Linn Kairn after our various bits and pieces here. So we've done a whole investigation into the noise output of this thing and found it's more characteristic than anything. And we've done a mod to give us a low level output on one of the outputs there, and that definitely makes a difference. You know, when I connect it up to these power amps here, I can hear it's much quieter, so that's all good. And we've done some recapping both in the main board and in the power supply and on the front panel, and we've changed the battery and fixed this flap here. So I think we're ready to play some music and see how it sounds.